I now turn to Dr. Sreekumar. Space research activities, hitherto have been focused on developing space assets that provide direct developmental benefits, like telecommunication sector or remote sensing and the things like that. But over a period of time, in the last year, we have seen there is an increase in exploratory activity by the India's space agencies and India's space programs. What can you tell us about the space explorations, and what lies in future as far as the space explorations are concerned for our great country, Bharat?
Thank you, General Mathur. Nearly 70 years ago, when the space exploration began, Van Allen, a very famous American scientist and team, had actually sent up a little experiment to see how space is. And they measured a lot of charged particles in space. And there was this big concern at that stage: was space radioactive? And is it a place where humans can actually go? Now, a lot has happened since then. And the idea of actually exploring space to understand the environment has been a continuing process. And ISRO also had a role to play in these aspects. As Dr. Guru Prasad mentioned, in balancing the resource and communication requirements of the country, there was also a parallel program that looked at space sciences right from the first satellite Aryabhatta onwards. And today this legacy continues with these new space science missions, as General Mathur just now suggested. And it has three basic areas we look into. We look at Earth from a space platform, both to look at resources as well as study Earth as a system. So in this particular area, we have a very exciting mission coming up called NISAR. It's a joint mission with NASA. Together, along with NASA, ISRO is building a synthetic aperture radar. It's a radar that can actually sort of artificially create an antenna dimensions larger because of it being on a moving platform. And using the two synthetic aperture radar, we can actually map and monitor changes in the vegetation and wetlands, ice, glaciers. An absolutely important issue that will look at land surface deformation, look at earthquakes, volcanic activity. It's a very, very important mission that is expected to be launched very, very soon. And this is together with NASA, and NASA today sees this as a very, very important mission. And that speaks volumes about the kind of leverage that we currently have globally. We're also looking at a possibility of a twin satellite that studies the upper atmosphere of Earth. And this is right now, as part of every activity, we build study reports and then present requests to the government for formal approval. Going beyond Earth, if you look at the planetary exploration, Dr. Guru Prasad already mentioned the challenges and the exciting results from Chandrayaan-1. Chandrayaan-2 is a much more global, ambitious program. And today we have in orbit an orbiter that is world-class. It's got 8 experiments that are really pushing the observation capabilities of studying the moon. And today, moon is not something that is just for the scientists. Moon is for everybody. People are planning to go there. It's a place that we think of as resources. And so Chandrayaan-2, with its unique capability, is expected to address many, many elements of this, including the presence of water at poles. And there's a future mission that we believe with the Chandrayaan-3 and the future mission, we'll actually be able to contribute significantly in this process. The mission beyond Chandrayaan-3 is something that we're trying to do jointly with our Japanese exploration team, space agency, JAXA, which is a mission to land on the southern pole of the moon with a rover to really look for those pristine water that came potentially from the very early days of the solar system. And water, as you all know, is something that is essential for survival, essential for resources, for maybe rocket fuel, hydrogen, various other issues. We're also looking at the possibility of a mission, an orbiter mission to another planet of the solar system, Venus. And that is also at a very mature level with regard to study report and readiness towards a possible future mission. Going beyond our solar system, if you look at astronomy, as Dr. Guru Prasad already mentioned, we've had a very successful mission, AstroSat, which is continuing to observe. It's an observatory that is not just used by colleagues in India and scientists in India, but globally. We do open up observation capability to our global scientists, and about 50% of proposals we get from our global partners. And so it is seen as a very important mission that actually looks at space, looks at black holes, neutron stars in our galaxy, in galaxies beyond our own Milky Way, and in different parts of the world, of the universe. Later this year, we hope to launch a mission, which is all being readied now, to study the sun. It's called Aditya L1. It goes to a unique position between sun and earth called the Lagrange point 1, which is a perfect place to study the sun continuously. There's also an important place from where you'll actually get early warnings regarding how the sun may be behaving in a manner that would be of concern to us, what is often called as space weather. Are there disturbing influences coming from the sun in terms of particles, in terms of fields that could affect our communication, that could affect our satellites, could affect health of astronauts, that could affect satellite systems in terms of disturbances, etc. So it's a very important mission. It is also trying to do fundamental science of trying to ask what heats the sun, what heats the corona of the sun, which is extremely hot. So it's seen as a very major science solar physics mission. And we also have smaller missions like a mission called XPOSat. It looks at the unique behavior of polarization from X-ray emitting objects. It's pushing a new frontier of scientific research. Now, we've also embarked on a program to send Indians into space called Gaganyaan program, which is a very important program. It actually challenges us to really push our technology to a completely new frontier, reliability of many orders of magnitude better. And it also offers a great window to do microgravity experiments where the gravity that we experience on Earth can actually be removed, and you can study fundamental sciences that says, how does, say, two fluids that don't mix, how do they flow in a tube? How does fire behave in a zero gravity environment? It is also very important to really understand elements of this as we look at our own colleagues, Indian citizens being in space, how to ensure we actually do all the necessary R&D towards that. It also initiates a program in astrobiology, biology of how systems may evolve in space. Where did life come from? From Earth, or did it come from outside? There are many elements of it that are upcoming, which I think is only a sampling of the many missions that we are planning. As you can see, these are exciting, challenging programs, and they should motivate youngsters in the country to get involved and hopefully contribute to future programs of ISRO. Thank you, General Mathur.